Alright guys, so today we are going to be working on pulse width modulation in Arduino IDE. So the first things you're going to do is to create a variable. And the variable we are picking is a pin number. So the default pin for this LED here is 8. So we're going to be picking the pin number 8 and using it in the code. So we're going to be picking a variable, let's just say mango. So it's an integer, so we say int mango is equal to 8 and then semicolon. And we set the pin mode to as an output, so mango is output. Now when it comes to pulse width modulation, we are generally talking of analog signals. So in digital signals, we just have 1, 0, which is high or low. Basically what it means is if you have high for an LED, when you have high, it means that the LED is on, and when you have low, it means that the LED is off. So you can represent that in Arduino IDE by writing high or low. But when you come to analog signals, you are talking of regulation of brightness. If you supply, what do you call it now, power to this LED, it should just come on, and if you take the power away, it should go off. But then when you want to regulate the brightness, giving it, let's say the amount of voltage you give to this LED is 5 volts. If you want to regulate the brightness, you agree with me that you have to reduce the amount of voltage you give to the LED, you supply to the LED. So what you're going to be doing in pulse width modulation is using a range of values to determine how much of voltage is supplied to the LED. So in pulse width modulation for LEDs, it varies from 0 to 255. I think that's an 8-bit system. So 2 raised to power, I think 2 raised to power 8 should be or give around 256. So it just ranges from 0 to 255. That's the value. So 0 automatically becomes low, which is 0 volts, and 255 becomes high, which is 5 volts. So in between those values of 0 and 255 or 256, but we use 255, in between the values of 0 and 255, any of all those values which you pick, it will have a corresponding voltage value. So let's say if you pick 0, it is 0 volts. If you pick 255, it is 5 volts. If you pick around 100 or 150 thereabouts, you should have something around like 3 volts or so. So the brightness of this LED cannot be the same if you pick a value that is low, far away from 255, and definitely it cannot be, high enough. The brightness cannot be high enough or as intense as it ought to be if you pick a value around 1, 10, 20 and thereabouts. So what we're going to do right here is analog write. In the first video I made, we use digital write. It's just digital write. Then you call the pins variable, and then you set the value to high or to low. But today we're going to be using analog write. So we're going to write analog, okay, analog caps lock write. And then we are going to be using the pins. I actually forgot to tell you something. I'm going to be using this LED on this Esp32-c3 module. I think the manufacturers, they made a mistake on this module. The LED, they set it to low. So when I give it low, that is 0 volts, it will actually come on. And when I give it high, it actually goes off. So what is going to happen right here is if I give it 255, it is going to be 0, that is not going to come on, and when I give it 0, it's going to come on. So actually let's even try to experiment that. So let's just give it mango, and then we set that to, remember I said if we set it to 255 it's going to be low. Normally if you use it for any LED it's going to come high, but the way they connected this LED, they set it in such a way that the 255 is going to make it low. So 255, and then don't forget the semicolon. I don't think there's any need for delay right here, so let's just upload this. Alright, I think you can see that now. The code has uploaded and you can see that it's flat out. There's no brightness and there's nothing like that. So we're going to be using 255 as low and 0 as high. So let's go to do something in this code. You know, we have a range of values from 0 to 255, of which in our case is 255 to 0. So we're going to be getting this LED to have 3 levels of brightness. I'll try as much as possible to divide the numbers to ensure that you can at least see the brightness through this LED. So what we're going to be doing here is applying delays. We're going to apply delay of like 3 seconds. So delay, remember we don't just write 3, it is 3000 milliseconds because 1000 milliseconds make a second. So 3000 milliseconds, your semicolon, then analog writes and this time we're going to pick 200. That's like short by 50 or 55. Okay, yeah, I forgot the variable. Semicolon, and then a delay of 3 seconds. Then we're going to do analog writes okay, so we're going to pick let's say 150 semicolon. I think we're going to pick let's just go directly to 50, or let's use 70. Let's use 70. So analog writes delay 3000, and then the last one obviously is 0. All right, let's upload this. All right, it's done uploading. So you can see, I don't know if you can see it clearly, but it's increasing in brightness. I think that should be the last one. Goes off. So 255, 150, 70. Yeah. All right, so in the next video I'm going to be teaching you something else about pulse width modulation. Thank you so much.